Hi everyone, it's me, your storyteller Neutrino. Today we will talk about my friend and the light of my life, the photon. Have you ever wondered how rainbows or auroras are formed, or why the sky is blue? The photon is in charge of all of these and many other wonders of our universe. Humans have always wanted to know what light is made of. In about 300 BC, Euclid wrote Optica, in which he studied the properties of light. In the 17th century, Isaac Newton observed that a beam of sunlight hitting a prism with an angle creates a band of visible colors. Newton proposed his corpuscular theory, but he could not explain wave-like properties of light. At the same time, Christiaan Huygens proposed that light was emitted as a series of waves. In 1845, Michael Faraday found the first evidence that light was an electromagnetic vibration which could spread without a medium. Inspired by Faraday's work, James Maxwell soon concluded that light was a form of electromagnetic radiation and published his theory of electric and magnetic fields. Maxwell's theory was experimentally confirmed, and it led to the development of the radio, television, and wireless communications. In 1900, physicist Max Planck suggested that although light was a wave, it could lose or gain energy only in quantized form. This was the birth of quantum physics. In 1905, Albert Einstein showed that light not only traveled as waves, but also as packets of energy, which he named energy quanta. In 1923, physicist Arthur Compton at Washington University demonstrated the particle nature of light and discovered the photon, a particle of light. Soon after observing the behavior of electrons and photons, Louis de Broglie suggested that wave-particle duality is a feature of all particles. People sometimes compare neutrinos with photons. I have to admit that photons are the most abundant particles in the universe, and they are the fastest too. But let me say something. In a water pool competition, I would win. In water, we neutrinos go much faster than photons, but no particle can beat photons in a vacuum. Photons are also humans' favorites. They are your messengers. You send information using photons. But again, if you had to send your messages through the rocks, you better use neutrinos. Honestly, I admire photons just as much as you do, but we particles don't really compete. The photon is the only particle you can see with your eyes. Photons make this universe colorful for you, but on the fundamental level, objects don't really have colors. Color is your eye's response to certain types of photons. When I travel near the North or South Pole, I often see people amazed by spectacular light shows in the sky, called auroras. They are painted by my dearest friends, electrons, interacting with the atmosphere and creating glowing lights across the sky. I would give 1,000,000,000 years of my life to see an aurora or a rainbow in the sky, but we particles don't have eyes. Anyway, I must leave now. See you soon.